Hi, this is Dr. Lloyd White again, and this video looks at the neurovascular structures of the upper limb. So neurovascular structures move from one region to another by passing through anatomical spaces. And there's four different types of neurovascular structure. First, we have arteries, and these are responsible for supplying blood to a structure or a region of the body. Typically they have thick elastic walls and they remain round or don't collapse once dissected. So in our anatomical diagrams, they're typically these concentric circles here. Often running side by side with an artery are veins. In this case there's two, so they're venae comitantes. And these are responsible for draining blood away from a structure or a region. They're thin-walled, so only the single circle, so they often collapse in anatomical specimens. They can also appear darker. This solid black circle here is representative of a nerve, and nerves are the structures that carry the electrical impulses to and from structures or regions of the body. In anatomical specimens, they appear solid, often a matte white or cream colour, and often striped longitudinally, which represents the fascicles within that nerve all running in the same direction. And finally are these very small lymphatics, and these drain the fluid which is leaked out into the space around the cells of a structure or a region, otherwise known as the interstitial space. So the fluid that accumulates in this interstitial space gets collected by lymphatics and delivered back into the circulatory system after the lymph has been screened for pathogens. In our anatomical specimens, they're usually not visible. So the course of a neurovascular structure, like an artery or a vein or a nerve, can be defined in terms of its origin, or what it starts from, and its termination, or what it turns into. Can also be defined in terms of its course, or how it gets there. So by this what we mean is what spaces or regions is the structure passing through on its way from its origin to its termination. So if we use the axillary artery as an example, its origin is the subclavian artery, and it changes its name from subclavian artery to axillary artery as it passes the lateral border of the first rib. And the axillary artery terminates into the brachial artery as it leaves the axilla, so at the level of the inferior border of the teres major muscle. And its course can be defined as, so it enters the axilla through its apex, it passes through the axilla, so this is posterior to pec minor, and it enters the brachial region, or the arm region, by passing through the base of the axilla. So if you can also think of some other neurovascular structures that would be travelling with the axillary artery in the axilla. Now, nerves are obviously very important neurovascular structures in our bodies, and all of the peripheral nerves of our limbs originate from a nerve plexus, and this is a place where the nerves originate from more than one spinal level. And the purpose of a nerve plexus is to make sure that all the structures of our limbs are receiving innervation from more than just the one spinal nerve, so that if there's damage to one spinal nerve, there's still some innervation getting to the structures of the limb. Now, nerve plexus, as shown in this diagram, is where we have the additional combination of nerve fibres from adjacent ventral rami. And this reduces the number of peripheral nerves that we need to supply our limb structures. And it means that there can be literally dozens of different nerves originating from 4 or 5 different spinal levels. Now, important features of the nerve plexus are our spinal nerve coming out and splitting into a dorsal ramus, which will supply the back, and the ventral ramus, which will supply the front of our torso and all of our limbs. Now, this ventral ramus then splits into an anterior division and a posterior division. So we've got one ventral ramus splitting into an anterior division and a posterior division. So we have peripheral nerves originating from anterior divisions, and we have another peripheral nerve originating from posterior divisions from different spinal levels. And these nerves will end up supplying different structures and different compartments of the limbs. Now we're looking specifically at the upper limb. So the nerve plexus that we have in the upper limb is the brachial plexus. And this diagram here is a schematic representation of our brachial plexus. And I'll just run through the very basics of the brachial plexus first of all. Now the first step in looking at this diagram is to find out which spinal levels are involved. And for the brachial plexus, we have our cervical enlargement with levels C5, 6, 7, 8 and T1, all contributing into the brachial plexus. Now we can see many different peripheral nerves originating out of the brachial plexus. However, there are 5 major peripheral nerves that we need to know about the upper limb. So we've got our brachial plexus, we can see it all dividing and merging and dividing again, and we end up with anterior divisions, and we've got 3 of the 5 major nerves originating from the anterior division. We have the musculocutaneous nerve originating from the more superior spinal levels. We have the median nerve originating from all of the spinal nerves contributing to the brachial plexus, and the ulnar nerve originating from the more inferior spinal levels. So these 3 nerves are from our anterior division. We've also got 2 peripheral nerves originating from the posterior division, and these are our axillary nerve and our radial nerve. The axillary nerve will originate from the more superior spinal levels, while the radial nerve will receive nerve fibres from all of the spinal levels that contribute to the brachial plexus. So see how you go with describing the course of the brachial plexus, axillary artery and axillary vein, and how they run together, and which parts of the brachial plexus do they specifically run with. How are they associated to each other? Also make sure that you can accurately answer the learning objectives as listed for this lecture. And if you haven't done already, have a go at posting a question or answering another question on the LMS discussion forums. Let's see if we can get some good crosstalk going in discussion of anatomy. And this discussion of anatomy will help you to learn the material and to better understand the material that we cover. For more information and to help answer those questions, you can refer to your prescribed textbook and to the principles booklet. Thanks very much for your time. This is Dr. Lloyd White. Bye for now.